Hello class, I'm going to show you an example of how L'Hopital's rule is used. Let's say we had the limit as x approaches 0 at the sine of 3x squared over x squared. If you try to evaluate this limit using direct substitution by plugging in the 0, we're going to get the form 0 over 0. This is known as the indeterminate form, and we can't evaluate this function as it is. So we're going to have to use L'Hopital's rule, which involves taking the derivative of the top of the limit and the bottom without using the quotient rule. So if we take the derivative of the top, it's going to be 2 sine 3x times the derivative of the inside, which is going to be cosine 3x times the derivative of the inside, because of the chain rule, it's going to be 3. And the derivative of the bottom is just easy, it's 2x. I'm going to simplify the top using the trigonometric identity 2 sine x times cosine x is equal to sine of 2x. So that simplifies the top into the sine of 2 times 3x times 3 on the outside, still over 2x. Simplify that further, just going to be 3 sine of 6x over 2x. So we're going to evaluate it again using direct substitution. So if we take sine of 6 times 0, sine of 0 is 0, times 3 is still 0, and 2 times 0 is 0. So we're still in the indeterminate form, 0 over 0, so we have to use L'Hopital's rule again. So that involves taking the derivative of the top, which is going to be 3 times cosine of 6x times the derivative of the inside, which is 6, over the derivative of the bottom, it's going to be 2. So I'm just going to simplify that a little further. It's going to be 18 cosine 6x over 2. So we're going to evaluate it again. So we plug in 0. I'm going to get cosine of 0 is 1. So it leaves us with an 18 on top, a 2 on the bottom. So 18 divided by 2 is 9. So you can see here how L'Hopital's rule was able to take a function that was in the indeterminate form and turn it into a value.